Alright, so in this video, let's talk about gauge pressure. Now, when I think about gauge pressure, I mostly think about the pressure in the tire, like getting the pressure of the tire, which is just absolute pressure that is inside the tire minus the outside pressure outside of the tire, which is going to be atmospheric pressure. So our equation for gauge pressure, so I'm just going to put P gauge, so our gauge pressure is going to equal our absolute pressure minus our atmospheric pressure. Now, when we're also modeling this atmospheric pressure, we can also use P0. P0 is going to be pressure at the surface minus density times gravity and depth. It will be Z or Y in some cases, and then minus atmospheric pressure. So this is the equation that we're going to be using throughout all of our practice problems that we're going to be going through. So the first one says a tire is filled with air to a gauge pressure of 200 kilopascals. So when you're looking at pressure is going to be measured in these SI units of pascals, but we have kilopascals, so it's just going to be 1,000 times pascals. And what is the absolute pressure inside the tire? So we're looking for the absolute pressure. We're looking for this P over here. So let me change my colors over here. So we know that our gauge pressure is 200 kilopascals, and this is our equation. So just going based on this, we have 200 kilopascals, and we're trying to look for absolute pressure, so I'll just put P and then minus our atmospheric pressure, where we're assuming it's 100 kilopascals. So to isolate for our absolute pressure, all we have to do is just add 100 kilopascals on both sides, adding that, and this is going to get our absolute pressure being 300 kilopascals. Alright, so just to give you guys a sort of conceptual understanding when we're talking about gauge pressure, I want to ask you guys a simple question. So let's say we have a tire for, let's just say maybe like a Corolla. So I'll draw it over here. And let's say we also have a tire for a bike. So draw this over here. So this is for our bike, this is for our car. And relatively for cars, at least for a Corolla, we might see 33 to 35 PSI. PSI is just another SI unit to measure our pressure. There's also mercury, where that's seen those blood pressure cuffs. And over here we have our bike, where it's relatively, depending on the bike tire, but we'll just say 150 PSI. But the main point is there is a lot more gauge pressure in this bike tire versus this car tire. So why is that? Well, we bring up our equation, pressure equals force over area. So that's really important to know that pressure is just force over area. And pressure and area are inversely related. And since in our car tire we have more area, we'll have less pressure. But for our bike tire over here, we have less area, which means more pressure. Alright, so for our next question, now we're bringing in gravity and height. So it says a cylindrical tank is filled with water with our density, which is very important, we need to know this, is 1,000 kilograms per meters cubed to a height of 5 meters. So we're given our density, we're given our height, and we're asked for the gauge pressure at the bottom of the tank. We know our gravity is 9.8 meters per second squared. So in this scenario, our P0 meaning the pressure at the surface of this liquid, is going to equal the atmospheric pressure. So when our pressure at the surface equals the atmospheric pressure, then our gauge pressure is going to equal density times gravity times depth or height. So the reason why this is the case, and this only applies or mostly applies to when we're working with open liquids or any side of that liquid that's open to air, in which that surface is going to be exposed to the atmospheric pressure. So the pressure at the surface is going to equal the atmospheric pressure. So if we know that, then all we really have to do is just plug in our numbers. So we have density. Density is 1,000 kilograms per meter squared. So I'm just going to move this guy over here. Still using that equation, so this is going to be 1,000 kilograms per meters cubed. That's our density times 9.8 meters per second squared, which is our gravity. And finally, our height is 5 meters. Always make sure that your units are aligned with each other. So if this was, like, let's say this was just 50 centimeters, then you want to change that to meters. So once we solve that, let's see what we get. We get 49,000 pascals, or if you want to turn it to kilopascals, that'll be 49 kilopascals. All right, so now let's move on to our next question. And as you can see, these are getting incrementally a little bit more difficult. So we have a U-tube manometer containing mercury, and on one side it is open to the atmosphere. So since one of the sides is open to the atmosphere, we know that our surface pressure is going to equal our atmospheric pressure, and the other is connected to a gas supply. We have our height over here, which is 10 centimeters. And what is the gauge pressure in pascals, and what is the absolute pressure as well? So we need to find gauge pressure and absolute pressure. And we're also given atmospheric pressure. In most cases, it's going to be 1.01 times 10 to the 5 pascals. So let's actually try to, draw this out just to have a little bit more of a visualization. Oh, that was a terrible drawing. So let's just do this, and I'll just make this drawing a little simple. So we have one side that is exposed to air, so I'm just going to put this side as the open one, this side as the closed one, and over here the open one is over here, and the mercury level on the open side is 10 centimeters higher, so we'll just say this is 10 centimeters higher. Okay, so we have our sort of visualization. We know that our pressure at the surface equals the atmospheric pressure. So all we have to do is know that our gauge pressure in this scenario will equal density times gravity times depth, or y, or we have the height. So all we have to do is plug in our numbers. So this is going to be 13,600. I won't put the units just to make it a little bit more simple. And gravity, per usual, 9.8 meters per second squared. And our height over here is 10 centimeters. Now we need to convert that into meters. So 10 centimeters to meters is just going to be 0.1 meters. And when we do that calculation real quick, we are going to get 13,328 pascals. Not kilopascals yet. Or if you want to do kilopascals, it would be 13.3 kilopascals. But I'll just leave the pascals part right there. So we now found our gauge pressure. Well, how are we going to find atmospheric pressure? Or, how are we going to find the absolute pressure? Well, we know our equation, which is our gauge pressure equals absolute pressure minus atmospheric pressure. So let's say that we wanted to find our absolute pressure. Well, we would just have to plug in our numbers and, sort of isolate for our absolute pressure. So when we isolate for this variable, it's going to be absolute pressure equals gauge pressure plus atmospheric pressure, which we know this is just going to be 13,328 plus 101,000, and this is going to end up being 114,328 pascals. All right, so for our final practice question, I want you guys to actually find what the gauge pressure is and what the absolute pressure is for this scenario. All right, so we basically have a diver in a rigid sealed container, which is going to be 200 meters deep. So we know that our depth is going to be 20 meters. 20 meters. So the container has a pressure gauge inside that reads gauge pressure. So just saying, like, what is the gauge pressure and what is the absolute pressure? So we know our density as well. Since we're dealing with water, density of water is just 1,000 kilograms per meter squared. So we know this is 1,000. Gravity always given as 9.8 meters per second squared. So all we have to do is use our equation, which we're going to have our gauge pressure is going to equal, I'll do gauge equals our density density times gravity times our depth. So this is going to be 1,000, and this is times 9.8, and this is times 20. So if we do the math for this guy over here, we're going to get 196,000 pascals, or we can just make it simple and do 196 kilopascals. Now, what about finding the absolute pressure? Well, we know our equation for finding absolute pressure is going to be, and this is going to be absolute pressure equals the gauge pressure plus atmospheric pressure. So what this is going to be is, and our gauge pressure, which we found, was 196,000 plus 101,000, which is going to be 297,000 pascals, or to make it simple, 297 kilopascals. Now, before we leave this question over here, let us actually talk about the conceptual understanding behind gauge pressure and absolute pressure. So when our diver is in water, so let's just say this is the atmosphere, and actually let me get my highlighter to show this. So let's say this is our water. This is our water over here. And let's say the diver is actually in the water. So just model them like this. So our gauge pressure is just going to be the pressure from the water, from our fluid, which in this case we have water. Now the absolute pressure is gauge pressure plus what is outside in the world, which is our atmospheric pressure. That is why our absolute pressure, and we'll just put A over here, absolute pressure equals gauge pressure plus atmospheric pressure, while our gauge pressure over here is our, let's say this is 20 meters deep, just to go with our practice problem. This is our gauge pressure from that 20-meter deep freshwater lake where we have our density of water and gravity.